Good morning, everyone. I'm Dr. Mayank Pandey, Department of Physical Sciences, Electronics, Kristu Jayanti. Today, we are going to talk about noise and transmission lines, which is a part of the communication system. At present, the syllabus or the content which we are going to deal with, internal noise. There are different types of which will be triggered during the communication system: thermal noise, white noise, short noise, partition noise, external noise, atmospheric noise, industrial noise signal, and then we'll be studying the signal to noise ratio. And then, uh, based on that, what are the different transmission lines through which we can transmit the content or the information or message from one to another or sender to receiver. So we have the T lines, then we have different types of coefficient, and what are the radio waves, electromagnetic is how it travels. These are the things which we are going to deal in this particular thing. Now, if you define the noise is an unwanted portion of the electrical signal that interferes with the actual information. So if you see that there are different types of information. So if I have the digital information which is in this format, and due to different types, and then you have a noise which is generated by different paths. It will be internal or external noises, and when we have to send the information through the transmission line, how the noise will be captured or how noise will be taken on the information is like this. So this particular signal is the noise signal or the message which will be a text message. So when the receiver will be receiving, sender will be sending, this noise will be happening towards the transmission or after while sending the information from to another. So when the information will be sending from one to another, we will be getting certain. So if the signal will be noised or disturbed, receiver will not be able to get the information in the right. So for that we have to reduce the noise or filter the noise in by different method mechanism. So here you can see that even if you have the this is the input or the message which is having noise, this is a kind of weak noise or the slight noises is there due to the little transmissions, and this is the optimal noise or maximum noise where you cannot find any kind of information uh, over the receiver. Okay, so, and this is the highest noise where you can the signal is completely disturbed by the different types of noises. Now the classification of noises. The noises are classified into different types. One is called external noise and one is called the internal noise. So here you can see that you have external noise are divided into atmospheric noise, extraterrestrial noise, industrial noise, thermal noise, and internal noise is divided into the thermal noise, short noise, transition noise. So let's see what is the atmospheric noise. The noise which when the signal is traveling from to another during that time due to different atmospheric conditions, due to different atmospheric stuff. So the major thing will be like the strong natural electrical disturbance. If this type of disturbance is called the static noise, this dominates very low and which is inversely frequency. And the next is extraterrestrial noise, which is solar noise, cosmic noise, industry, and then another one is called the industrial noise. Then we have the thermal noise, which is another thermal noise. Now here, the noise which is generated due to the random motion of a is called thermal, and or void or Johnson. The power of the noise which is generated through thermal is directly proportional to and the Boltzmann, so which can also be written as Pn is equal to KPV, where Pn is a magnetic power output system, K is a Boltzmann constant, T is the absolute temperature, bandwidth and B is the bandwidth for which noise. So the voltage of the noise signal can be calculated by under root 4 kTBR. Now there is another called short noise. So the noise produced by the random molecules across sections are called short noise. Then you have a in this you have a transit time noise and partition noise. What is the partition noise? Is noise occurs whenever current paths and results from the division. And the important term is called the signal to noise ratio. Signal to noise ratio is then signal of the power of the signal which is transmitted and divided by power of the noise signal, which is so signal to noise ratio can be calculated by the voltage square of this, the voltage square of the. Then another thing is called the noise figure, which is the signal to at input divided by signal to out. Have some